Hey everyone, welcome to Studying with Jen. Today we're going to be doing quadratic sequences. Okay, so to start off, a quadratic sequence has a general formula that looks like this. Tn is equal to a n squared plus b n plus c, where a cannot equal 0. So a quadratic sequence will have a general formula that has a trinomial. Okay, so let's map out what a quadratic sequence looks like. So here we have 5 terms, they form a quadratic sequence, okay? This is going to be the first difference row. The first difference is going to look like this. I'm going to call it, I don't know, x, right? Then it's going to be x plus d, x plus 2d, x plus 3d. And doesn't this look familiar? This over here is basically an arithmetic sequence. So, a quadratic sequence has a first difference of an arithmetic sequence. Then, let's move on to the second difference row. Here we have a difference of just d. So the second row's constant differences are basically just the constant differences of the first row. Okay, so the next thing is I'm going to give you all the formulas you need to memorize for this section. Okay, so we have 2a is equal to the constant second difference. In this case, this is equal to this. Then the next one is 3a plus b is equal to the first difference. I know that sounds confusing, but when I mean the first difference, I mean the first difference in the first row. So this over here is equal to this. Then we have a plus b plus c is equal to your first term. So this is equal to T1. So this means that this over here is equal to this over here. So one thing to note is we use simultaneous equations with these to calculate our a, b, and c in the Tn equals an squared plus bn plus c. Okay, so let's go straight into an example so that we can kind of see how to do these questions. The first things first is to map out our problems. This is to help us identify what kind of sequence we're actually dealing with. So first things first, what's the constant difference between 2 and 5? It's 3. 5 and 10, 5. 10 and 17, 7. 17 and 26, 9. 26 and 37, 11. Then we know that this is not constant, so we're going to do it again. Let's map this out. Then, between 3 and 5 is 2. Between 5 and 7 is 2. Between 7 and 9, 2. 9 and 11, 2. Now that we have this, we can use these formulas. 3a plus b, a plus b plus c. So let's calculate these. My best advice, start at the bottom. 2a is equal to 2. Divide by 2 on both sides, a is equal to 1. Then we have 3a plus b is equal to 3. Now we've already solved for a, so we can sub it into there. We're going to say 3, 1 plus b is equal to 3. We're going to subtract 3 on both sides and we end up with b is equal to 0. One thing to note is that b and c can equal 0, it's just a cannot be equal to 0. If a was equal to 0, then it wouldn't be quadratic. Then we're going to move on. We said a plus b plus c is equal to 2. Now we have a and b, so we can sub them both into here. We're going to say 1 plus 0 plus c is equal to 2. This is just equal to 1 plus c equal to 2. We minus 1 on both sides and we end up with c is equal to 1. Now, we have a, b, and c. We can sub it into our formula. Our formula is Tn equals an squared plus bn plus c. So our a value was equal to 1n squared, our b value was equal to 0n, and our c value was equal to 1. So our answer is just n squared plus 1. This is the formula for the general term. Okay, so let's go straight into examples so we can see what we're dealing with and just practice how to use our formulas. So first things first, let's map this out so we get a good idea of what we're dealing with. Between 6 and 17, there's a difference of 11. Between 34 and 17, we have a difference of 17. Between 34 and 57, we have a difference of 23. Now we can see that these are not the same, so we're going to do it again. So let's map this out again. The difference between 11 and 17 is 6. 17 and 23, also 6. So now we have a constant second difference. Then, the first question asks us to determine the next two terms. How do we do this? We know that that 6 is going to stay the same. So we're going to put a 6 there. Let's add another one just to be safe. Then, we're going to go 23 plus 6 is 29. 29 plus 6 is 35. Then, 57 plus 29 is 86. And 86 plus 35 is 121. So there, we've determined the next two terms. So term 5 is equal to 86 and term 6 is equal to 121. The next question asks us to determine the nth term. So we know that this 6 is equal to 2a. We know that this is equal to 3a plus b. And we know that this is equal to a plus b plus c. So we're going to start off with 2a is equal to 6. I divide by 2 on both sides and I end up with a is equal to 3. Remember, a cannot be equal to 0. Then we say 3a plus b is equal to 11. I've solved for a, so I can sub it into this formula over here. 3, sub in your 3, plus b is equal to 11. I have 9 plus b equal to 11. Subtract 9 on both sides. B is equal to 2. Then I'm going to say a plus b plus c is equal to 6. Now I've solved for a and b. I can sub them into this formula. I'm going to say 3 plus 2 plus c is equal to 6. This is equal to 5 plus c is equal to 6. Subtract 5 on both sides. C is equal to 1. Now we have all of our solutions, so we can sub it into this formula. Tn is equal to an squared plus bn plus c. Tn is equal to 3n squared plus 2n plus 1. Then question C asks us to determine which term equals to 161. So we want to calculate n. So we're going to use the formula we've just calculated. Tn is equal to 3n squared plus 2n plus 1. We're going to take this part and we're going to make it equal to 162. So we'll have 162 is equal to 3n squared plus 2n plus 1. We're going to move the 162 over, and we're going to have 0 equals 3n squared plus 2n minus 161. Now we're going to use our quadratic formula. The quadratic formula gives me an answer of 7, and it gives me an answer of negative 23 over 3. Now, a position can never be negative. We cannot have a negative position. The positions are always positive. So put a cross through that, and this is our final answer. So the next question is a little bit tricky. It says determine the 100th term of the first difference row. So now, if you guys remember, the first difference row makes up an arithmetic sequence. So I've just drawn this in quickly so we can have a look at this. This is the first difference row. So this is the number pattern we're looking at. So let's rewrite it real quick. We have 11, 17, 23. So we're almost treating it as its own number pattern now. Let me map it out. First things first, we need to find the formula of the general term. We know that as Tn is equal to A plus n minus 1 d. Tn is equal to, remember, A is our first term. So A is 11 plus n minus 1. Our difference is 6. Then we're going to simplify this. Tn is equal to 11 plus 6n minus 6. Tn is equal to 6n plus 5. Now we have the formula for the general term. Now we can sub 100 into n. They've given us a position. N is equal to 100. So let's sub that in. Term 100 is equal to 100 plus 5. Term 100 is equal to 605. Let's have a look at an example with variables. Here we have 6, 15, x, and 45. So first things first, what do? We map it out. So the first difference between 6 and 15 is 9. The second one would be x minus 15. The third one would be 45 minus x. Now this is a quadratic sequence, so we know that there is a constant second difference. Let's map out this difference. The first one is going to be x minus 15 minus 9. The second one is going to be 45 minus x minus 15. Now we know that these differences have to be equal in a quadratic sequence. So we are going to equate them. So let's start off. We're going to say x minus 15 minus 9 is equal to 45 minus x minus x. Don't forget to sub that negative in there. It's going to be plus 15. I'm just going to simplify each side. It's going to be x minus 24 is equal to negative 2x plus 60. Now I'm going to move the x's to the left. We're going to have 3x is equal to 60 minus negative 24 is equal to 84. We're going to divide by 3 on both sides and we end up with x is equal to 28. And that is the answer. So let's have a look at a word problem. Here it says the constant second difference of the quadratic number pattern 4x, 8y, 20 is 2. Determine the value of x and y and hence determine the term that equals 125. Okay, so first things first, what do? We always map it out. So we are going to say this first one is x minus 4. The second one is 8 minus x. This one, y minus 8. And this one, 20 minus y. They tell us that the second constant difference is 2. So which one is the second constant difference? It's this one. So these are all equal to 2. Now, we know that this is equal to this minus this. So we can write 8 minus x minus x minus 4 is equal to 2. We're going to simplify this. This is going to become 8 minus x minus x. Don't forget to take the negative, plus 4 is equal to 2. We're going to simplify this. It's going to become negative 2x equals, I'm going to move the numbers over to the right-hand side, negative 10. Divide by negative 2 on both sides, and we get x is equal to 5. Then we know that this minus this is 2. 20 minus y minus 8 is equal to 2. We're going to simplify this to 20 minus y, don't forget the negative, plus 8 is equal to 2. We simplify this to negative 2y is equal to, I'm going to move all the constants to the right, 2 minus 8 minus 20. And that gives us negative 26. Divide by negative 2 on both sides, and I get y is equal to 13. Now I've solved for x and y. Determine the term that equals 125. We need to actually calculate the formula for the general term first. So we know that this is equal to 2a, and we know that this is equal to 3a plus b, and we know that this is equal to a plus b plus c. So we can start by saying 2a is equal to the second difference, which is 2. Divide by 2 on both sides, a is equal to 1. We also said that 3a plus b is equal to x minus 4. Now, we've solved for x, and we've also solved for a. So we can solve for b. 3, 1 plus b is equal to, substitute x in, which was 5 minus 4. We end up with 3 plus b is equal to 1. Subtract 3 on both sides, b is equal to negative 2. Then we said a plus b plus c was equal to 4. We can substitute a in, and we can substitute b in. Negative 2 plus c is equal to 4. We can simplify that to negative 1 plus c is equal to 4. We add 1 on both sides, c is equal to 5. Now we can sub a, b, and c into this formula. Tn is equal to an squared plus bn plus c. Tn is equal to 1n squared plus negative 2n plus 5. And the formula is Tn is equal to n squared minus 2n plus 5. Now we can determine the term that equals to 125. So we're going to make the main formula, the general formula, equal to 125. So we're going to say 125 is equal to n squared minus 2n plus 5. I'm going to move the 125 over, and I'm going to get 0 equals n squared minus 2n minus 120. Now we solve. We get our brackets. We're going to factorize n minus 12, n plus 10. And we get a solution of n is equal to 12, or n is equal to negative 10. Now remember, n can never be negative. Never, 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 never can it be negative. So we cross it out, and this is our final answer.